AI. It's
Yeah.
everywhere, right? I mean, every day there's some new headline about it doing something amazing, like self-driving cars or even AI doctors.
It's incredible how fast this technology is moving.
Yeah, but it makes you wonder, like, can AI really understand the world the way we do? I mean, can it actually see?
That's a big question.
It is a big question, and that's exactly what we're diving to today. You sent over this research paper. How hard are computer vision data sets?
Hmm.
And wow, it really makes you think twice about how AI sees things.
It's a really fascinating look at what AI struggles to recognize, even with all the advancements in the field.
Yeah, and one of the things that jumped out at me was this idea of minimum viewing time, MVT. They basically measured how long it takes a person to look at an image and understand what's in it.
Right, so it's like a measure of how complex an image is for us humans to process.
Exactly. And the researchers, they use that MVT as a benchmark to compare with how AI systems do.
Yeah, because we're still the gold standard when it comes to vision, right? We might not be perfect, but we're pretty darn good at recognizing objects.
So what happened? Did the AI systems like struggle with the same images that take humans longer to figure out?
Well, they tested this on two main data sets that are used to train AI. ImageNet, which is kind of the go-to for object recognition, and then ObjectNet, which is supposed to be much harder for AI.
Okay, so ObjectNet is like the really tough exam for these AI systems.
Exactly. And you'd think with ObjectNet being designed to be harder, that it would also take humans longer to decipher those images,
Right,
right?
that makes sense. Harder for AI, harder for humans, right?
Yeah. Well, here's the kicker. They found that even though ObjectNet was much tougher for AI, the images weren't actually that much harder for humans to recognize compared to the ones in ImageNet.
Wait, really? So even with this supposedly super challenging data set, we're still basically feeding AI easy mode images.
It seems that way.
So we're basically saying that 90% of the time AI is getting a free pass. That's kind of a big deal, right?
It is. It really throws a wrench into how we've been evaluating these AI systems. We're judging them based on this ideal scenario, not the real world.
It's like we're testing them on a perfectly flat racetrack and then expecting them to win the Indy 500.
Exactly. Think about it. Self-driving cars, right? They need to navigate through rain, snow, even just a freaking squirrel crossing the road.
Okay, yeah. That's way more complicated than a sunny day and a clear road.
Way more complicated. And it's not just self-driving cars. Think about medical imaging. An AI has to spot tiny details, sometimes in blurry scans.
Oh, wow. Yeah. Or even something as simple as like sorting your photos. That can't be easy for AI either.
Not really. Different lighting, angles, all sorts of things that we take for granted AI can really struggle with.
Okay, so we're maybe setting these AI systems up for failure by not giving them a good enough training ground.
That's the worry. They need to be able to handle the chaos of the real world, and right now it seems like they're not quite there yet.
You mentioned earlier that the paper had some examples of these really tricky images. What are some of the things that were tripping up these AI systems?
So if you look at figure 3 in the paper, you'll see this range of images. Some are super easy for humans to figure out, but others, not so much.
What makes them so hard?
Well, some have really weird lighting, or the object's hidden, like a dog, but you can only see its tail. Things like that.
So it's like context clues, right?
Yeah.
Humans, we use them all the time without even thinking about it, but AI, not so much.
It's one of the biggest hurdles in AI vision right now. They haven't quite cracked the code on how to understand context the way we do.
So how do we fix that? I mean, it can't be as easy as just like taking more pictures, right?
It's definitely not that simple. One thing that researchers are really digging into is how these models scale.
Scale. You mean like make them bigger, feed them more data. Because isn't that what we usually do with AI? Just make it bigger.
It is, but what this research is saying is that that might not be enough. They found something pretty interesting when they looked at how AI performance changes as you scale it up.
So what they find? Does making AI bigger actually help it, see those harder pictures?
Well, that's the thing. They found that, yeah, most AI models, they get better with more data, but only up to a point, like with the easy stuff. But when it comes to the really tricky images, it's like they hit a wall.
They just can't figure it out. No matter how much you try to like supercharge them.
Pretty much, they plateau. But here's the difference. Humans don't seem to have that same limitation. We can recognize a coffee cup from any angle, even if we've only ever seen it from one side. AI, at least not yet.
Okay, so what's the solution here? Are we just stuck with AI that can only handle the easy stuff?
Well, there might be some hope. Remember CLAP? that model we talked about earlier, the one that uses both images and text.
Right, right. The one that's like learning from captions and labels and stuff.
Exactly. That seems to be the key. CLIP, it actually scales more like humans do. As it learns, it keeps getting better, even with those harder images. It doesn't plateau like the other models.
So it's like those captions, they're giving CLIP extra information, right?
Yeah.
Like teaching it context in a way that just showing it pictures can't.
You got it. It's like instead of just seeing a picture of a cat on a couch, CLIP is also reading, this is a cat relaxing. It's getting a more well-rounded education, you could say.
That's really interesting. But you said it's still early days for CLIP. Could it be that it just hasn't hit that wall yet, that eventually it'll plateau too?
It's possible. We need more research to know for sure, but for now, it's definitely a really promising lead.
It's like a glimmer of hope in this whole like AI vision puzzle. But what about the models that did struggle? Did the researchers have any idea why? Like what was going on in their AI brains?
They tried to figure that out. One thing they looked at was how quickly the AI learned to recognize an object. Turns out the images that took humans longer to process also took the AI longer to learn.
Hmm. So it's not just about what's in the image, but also how easily the AI can make sense of it. Like some things just click better than others.
Yeah, kind of like that. And they also looked at how deep in the AI's neural network the decision making was happening. The harder the image, the deeper the AI had to think about it.
So even though we're building these incredibly complex AI systems, we don't totally understand how they like actually see the world.
We're getting there, but there's still a long way to go. This research really highlights how much we still don't know.
This whole deep dive has been a real eye-opener. We get so caught up in the amazing things AI can do, but it's important to remember that it's not perfect. Not yet, anyway.
Definitely. And understanding these limitations is key to moving forward. It's not enough to just build bigger and bigger AIs. We need to think smarter.
We need to teach them not just to see, but to actually understand. Well, on that note, I want to thank you so much for joining me for this deep dive. This was fascinating.
It was my pleasure. Always happy to talk about the wonders and the challenges of AI.
And for our listeners, if this got you thinking about the future of AI and how machines perceive the world, well, you're in the right place. We're going to keep digging into these questions, so make sure you subscribe and join us for the next deep dive.